Today we are going to discuss behavior wise classification of cost. Behavior wise classification of cost and application to management decisions. So, first, classification of cost. In this case, we are discussing on the basis of behavior of cost. What behavior? Behavior means cost can be classified fixed cost, variable cost, and semi-variable cost. Fixed cost means which cost? Rent means factory rent, fixed salary, manager salary, management salary, like that, legal expenses, and any other fixed cost which is not changed with production units, other fixed cost. Okay. And variable cost. Which are the example of variable cost? Direct material cost, direct labor cost, direct expenses. All these are the variable cost. Semi-variable cost. Which are semi-variable cost? Like depreciation, electricity, telephone charges, repair maintenance, etc. I'm going to discuss through graphs each of these costs and how it behaves. First of all, that's why it is written as graphical presentation. First, I'm going to discuss the fixed cost. Fixed cost means which remains fixed for a particular period with units of production. Say factory rent. Now we are considering the period, say 1 month. The 1 month rent is say 10,000. So if you produce 1 unit or no unit, still you have to bear 10,000 of cost. And if the production increases to 1,000 units, it is given in 1,000 units, 2,000, 3,000, 4,000. Say the full capacity for the period is 10,000 units, still the fixed cost remains 10,000 rupees in 1,000. This is the concept of fixed cost line. That's why the line is a straight line parallel to x-axis, units of production. It indicates if you produce 0 units, still the fixed cost is 10,000. If you produce 1,000 units, then also the fixed cost remains 10,000. It does not change with the increase in production up to maximum capacity of the unit or factory for the period. This is the concept of fixed cost line. I have already mentioned here which are the fixed costs. Generally, factory rent. It is decided you have to pay say 10,000 per month. It comes under the fixed cost. Manager salary, whether units is produced or not, you have to pay, or staff salary. That is a fixed cost. Legal expenses means initially some legal expenses for a project is required for registration of land or so many legal reasons. That is also fixed. It will not change. So this is the concept of fixed cost line. First of all, I am discussing the 3 costs as I have already mentioned. Then we will discuss in slightly different way, that is per unit. Now variable cost. Now comes to the variable cost. Variable cost means what? Variable means it varies proportionately with the production of units or units of production. Say the cost for producing 1,000 of units is rupees 1,000. And if you produce 2,000 of units, then proportionately the cost will be increased to 2,000. Cost for 1,000 is rupees 1,000 means per unit variable cost is rupees 1. That's why if you produce 2000 units, proportionately the cost will be increased to 2000. If you produce 3000 of units, then again proportionately the total variable cost will be 3000 of units. In this way, if you produce 4000 of units, then the variable cost will be rupees 4000. And that's why the line is passing through the origin, and proportionately the line is increasing. So this is the variable cost line. Now semi-variable cost. The name itself is clear. Semi-variable means partly fixed and partly variable. I have already mentioned earlier the examples of semi-variables. Say depreciation. Why depreciation is semi-variable cost? Because if you purchase and install any machine for production, if we use or not, with the process of time, some cost will be incurred or the value of the machine will be decreased. That is the fixed component of depreciation. Uniformly, it will be decreased. But if you use the machine one shift, second shift, third shift, like that, with the increase in production, the depreciation rate will be higher. If you produce less, then the depreciation will be less. And if you produce more, then depreciation will. That's why, in the case of machine, partly it is fixed and partly relates with the units of production. If you produces more, then depreciation will be more. Similarly, for electricity charges, if you consume electricity or not, you have to pay a minimum bill for the electricity to the electric department. That is the fixed electricity charge. And the electricity charges will be increased proportionately if you increase your units of production, if you consume more and more electricity. Repair maintenance also like that. You have to bear a minimum fixed expenses regular basis to maintain the machines or assets of the factory or your office. And with the increase of production, it will be increased more and more. That's why this type of costs, depreciation, electricity, telephone charges, repair maintenance, heats, so many items, which are semi-variable cost, means partly fixed, partly. That's why the graph of that type of cost is shown here. This portion is fixed. If you use or not, still this much of cost is required. And after that, with the increase in production units, the total semi-variable cost is increasing. That's why the shape of the line of semi-variable cost will be like this. To get it more clear, I am also showing you how the behavior of the cost will be per units of production. Here we have shown you the total fixed cost and units of production. But if you present it in this way, units of production is this and fixed cost per unit is your y-axis, then what will happen? Then it will be a decreasing curve like this. Why like this curve? Suppose your production capacity of the factory is 10,000 units. If you are producing only one unit from the factory, then what will be the cost per unit? Because you are producing only one unit for the period, then entire cost, that is rupees 10,000, cost per unit will be rupees 10,000. Now, if you increase the production units from 1 to 2, this is 1, this is 2, then what will be the fixed cost per unit? 10,000 divided by 2, that is 5,000 rupees, 5,000. In this way, if you produce 1,000 of units, and the total fixed cost is 10,000, then what will be the fixed cost per unit? Fixed cost per unit, that is rupees 10,000, total fixed cost divided by production 1,000, it will be rupees 10. In this way, if you produce 10,000 of units and the total fixed cost for the period is 10,000, then what will be the fixed cost per unit? That will be rupees 1. This is the maximum capacity of the factory. Fixed cost per unit will be rupees 1 only. If you produce 1 unit only, then the fixed cost per unit will be 10,000, and if you produce 10,000 units, then the fixed cost per unit will be rupees 1 only. That is, it is decreasing in nature. If you produce more and more, then the fixed cost per unit will decrease. But the total fixed cost line will remains fixed, because total fixed is not changing with the increase of production for a particular period. Keep in your mind, this is the difference. This is the total fixed cost line, and this is the fixed cost per unit line, you can say, line. You have to understand the behavior of the cost so that we can easily apply to our management decision making. That's why I'm explaining in detail the nature of cost. Behavior, why, how it changes. Now, come to variable cost. I have already discussed. Suppose the variable cost for 1000 units, variable cost for 1000 units is rupees 5,000. This means variable cost per unit is rupees 5. The cost per unit for variable cost is rupees 5. Now, if the whatever the production unit will be, the total variable cost will be increased, but per unit variable cost remains same, because that variable cost directly, that's why it is called direct material, direct labor, which is attached with the product. It can be seen in the product. Say the direct material cost or cost of steel rupees 5 per unit. If you produce more, the total variable cost will be increased, but the per unit variable cost remains same. It will not change. If you produce 100 unit and the cost per unit variable cost is 5, then the total variable cost will be 500. If you produce 1000 units and the variable cost per unit is rupees 5, then the total variable cost will be 5,000 in this way. But the cost per unit or the variable cost remains same. For each product, the variable cost remains same. If the units increases, the total variable cost will increase, but the per unit variable cost remains same. That's why this is shown as parallel to the x-axis, units of production and variable cost per unit. Say this is rupees 10. Variable cost per unit rupees 10. So if you produce say 1 unit, then also 10 rupees. If you produce 100 units, then also per unit variable cost remains same, but the total variable cost will increase proportionately. So this is the difference of the variable cost curve for total variable cost and per unit variable cost. For semi-variable cost, there are so many ways by which we can segregate the fixed cost and variable cost. That will be discussed in separate video. For application, for management decision making, it is very essential to segregate the semi-variable cost to fixed and variable portions. Fixed will be again remains same, and variable cost will be increased or decreased proportionately with the increase or decrease in production. Just like giving you the basic idea how you can segregate it. Suppose you are plotting the total semi-variable cost with respect to the units of production, and the cost for different units of production you are plotting on a graph paper. and this is called scatter diagram. In statistics, we have already learned the scatter diagram. This is the points of different total semi-variable cost with respect to units of production. I'm just suppose this is the total semi-variable cost is 9,000 for these units of production, and this is say 16,000. In this way, you are plotting the different total semi-variable cost points with respect to units of production. And now you pass a line over this point so that the deviation, total deviation is minimum. That means you try to pass the line in between all these scattered points so that the total deviation will be. Then this line will represent all these semi-variable cost. And from this line, it is very easy to identify this portion of the cost is the fixed cost, and if you find out the fixed cost, if you know the fixed cost, then it is no problem at all to find out the variable cost per unit. Say this is 100 units and your fixed cost from the graph comes to rupees 3000, and at 100 units the same variable cost comes to 4,500 rupees. This is total semi-variable cost. Then what is the variable cost per unit? You subtract this from this, that is 1,500 for 100 units. That is variable cost per unit will be rupees how much? 1,500 divided by 100, that is rupees 150. In this way, for any point you can find out, you can check the variable cost per unit remains same, and fixed cost you can calculate from the graph in this way. So this is the basic concept for behavior wise classification of cost. Why you have learned this? What is the purpose of this? That I am going to discuss. First of all, I am going to discuss the application to management decisions for the concept of break-even point with the help of this graph and where it can be used, and then we will discuss the other applications. Thank you. Yes, we are going to discuss the concept of break-even point. It is a very important application for management decision making, and how the break-even point analysis is done, that I am going to discuss now. I have already discussed the behavior-wise classification of cost in my previous slide. In that slide, I have discussed the total fixed cost line, total variable cost line, all this. Now we are plotting that lines on the same sheet or same paper, and this is the total cost line for any manufacturing unit. This is the total fixed cost line. We have plotted this total fixed cost line. I have already shown that total fixed cost line is parallel to its x-axis. That means with the increase in units of production, the total fixed cost line remains same. And this line indicates the total variable cost. You may say that in the previous slide you have shown the total variable cost is like this. This is units of production, and this is total variable cost. Then why you are writing or drawing the line in this way. Actually, this is not total variable cost line, this is total cost line. This is total cost line. Total cost means total variable cost plus total fixed cost line. Fixed cost line. And this is the total cost line. The total fixed cost line is like this. The total fixed cost line is like this. This is the fixed cost line. If you merge these two lines, then the total cost line will be this. Because when the units of production is 0, the total cost will be only total fixed cost. This is the total subtotal variable cost plus total fixed cost line. Because for 0 units of production, variable cost is 0. Now, as the units of production increases, say this is 100 units, say, then the total cost line will be this fixed cost plus the variable cost for 100 units. That's why the total cost line is slightly higher than this. But it is not passing through the origin as discussed earlier. This is the variable cost only. This is fixed cost. This is the total cost line. Total cost line means total variable cost plus total fixed cost. Total fixed cost remains same. As the variable cost increases, total variable cost increases with the increase in units of production. That's why the total cost line is showing like this. One thing I like to mention here that the basic assumption is that we have segregated the semi-variable cost into two components, purely the fixed cost and variable cost. That's why in this picture, in respect of cost, we have shown that this is the total fixed cost line and this is the total cost line where variable cost is included, but there is no semi-variable cost. So this is the total fixed cost line and this is the total cost line. If you not draw this line, then this is the total cost line and this is the total sales line. Why the shape of the total sales line is like that? Because the sales is proportionately going to be increased. If you sell one unit, say the sale price of it is 100 rupees, then total sale will be 100. If you sell 100 unit, 100 sales price per unit. If you sell one unit, then the total sales will be 100. If you sell say 100 units, then the total sale will be this is 1000 rupees. In this way, if you sell 1000 units, then what will be the sale? Then the total sale will be 1 lakh. In this way, the sale line will be proportionally increased with the increase in production. So this is the total sales line and this is the total cost line. Now you see this is the cutting point where total sales value is equal to total cost. That means total cost. That is what amount we have incurred for the production for this capacity or for these units of production is equal to the total sales value. There is no profit. And this is the point which is called no loss, no profit point. Whatever the sales revenue is equal to total cost. And this is the point which is called break-even point. The break-even point means that point where total sales is equal to total cost. Now we see below this point, for everywhere below this point, always the cost line is higher than sales line. If you check for any point, say this point, this is the total sales value and this is the total cost value. If total cost is higher than total sales, that means you are in loss. Here is also say 2000 units or 200, whatever it may be. This is the total sales line and this is the total cost line. Total cost line is higher than total sales value. If the cost is higher than sales revenue, that means you are in loss. In this way, till this, always cost is higher, just before this, cost is higher than sales value. That means always you are in loss. That means the company is in loss, the firm is in loss. And at this point, total sales value equal to the total sales revenue or sales. That means there is no loss, no profit. But if you move above this point, after this point, you can check always the sales line is higher than total cost line. If sale is higher than cost, that will be very profit. In this way, if you move the higher and higher order of production till the full capacity, say this is the full capacity of the farm or production units, always you will be earning more and more profit. That's why this is the profit area which is shaded by green. Through graph paper, the whole situation can be presented in this way. This is the break-even point, this is the loss area, and this is the profit area. And just I want to mention another thing also. This angle is called angle of incidence. What is this? That I will discuss. And this is the margin of safety. As a manufacturer or production manager or the owner of the company, why you are interested for this graph? What is the information coming out from this graph? The information is, this is the capacity of the whole capacity of the farm, where the farm will be in no loss, no profit. And after that, the farm will be always in profit. And below that, the company or farm will be in loss. And this point is called break-even point or break-even capacity, whatever. Say, this is 60% capacity of the farm. It indicates if the farm reaches to the 60% its capacity, then it will be no loss, no profit. And after that, it starts earning profit. And if the farm cannot produce and sell in the market less than that capacity, say 55% capacity, 58% capacity, the farm will be in loss. That means if the break-even point is higher, then it will be more risky for the manufacturer or the owner or production units of the farm. From this information, so many decisions can be taken. Suppose the financer who finance loan to new projects, projects A and project B. The financer always calculate the break-even point for both the project. Say for this farm, for this project A, this is project B, the break-even point is 46% and this is 64%. Then where the financer will finance as an investment? Definitely to this project. As low risk is involved here. In this case, high risk is involved. When the company or firm will reach to 64% of the capacity, only then it will be in loss profit. After that, it will start earning profit. That's why it is very important to know for any project what is the break-even point. From that, you can guess and you have the idea how much risk is involved to the project. Even if you are going to invest your precious money to different projects in front of you, you have to check the break-even points, and accordingly you have to take decision. If the break-even point is less, that means the risk is less involved to the project, and will get quickly earning from the project. That's why break-even point analysis is very important, and for this purpose, you should have the idea of total fixed cost line, total variable cost line, total cost line, total sales line. Now, what is angle of incidence? Angle of incidence indicate the profit earning capacity or earning capacity. If the angle is wide, if the angle is more, that means earning capacity is more. With the increase in production, the earning will be faster in respect of the lesser angle of incidence. Margin of safety. Margin of safety means this is the safety level for the investor, you can say manufacturer or the owner. Margin of safety means this is the gap in no loss, no point, no loss, no profit point, and this is the maximum capacity of the project, that is maximum earning possible from this project. And this gap is a margin of safety. It is a safety level. The manufacturer need not to face any risks of loss. So this is the concept of break-even point analysis, which is done through behavior-wise cost classification. In my next slide, I want to discuss the break-even point analysis through another aspect, through PV graph, that I will discuss what is PV graph and how we will apply it. And before that, some numerical formula is required to develop to solve numerical problems. That's why that will be discussed first, and then we'll discuss again the concept of break-even point through PV or profit volume graph. Thank you.